This video about basics of marine radars and ARPA use and legal implications of radar misuse. Often deck officers do not understand how to apply basic settings and data input correctly. As a result, they are using only part of marine radar potential. Wrong basic settings and data input convert radar from lookout power tool into useless, misleading device. These basic settings are gain, clutter C, clutter range scale and pulse length. They can easily make radar half-blind. Wrong basic and data settings of radar violate requirements of international collision regulations, known as COLREG. Rule 2. Responsibility. Nothing in these rules shall exonerate any vessel, or the owner, master or crew thereof, from the consequences of any neglect to comply with these rules or of the neglect of any precaution which may be required by the ordinary practice of seamen. Ordinary practice of seamen means correct basic settings of radar. If officer cannot explain in courtroom how he adjusts radar basic settings, there will be harsh legal consequences for him. Rule 5. Lookout. Every vessel shall at all times maintain a proper lookout by sight and hearing as well as by all available means appropriate in the prevailing circumstances and conditions so as to make a full appraisal of the situation and of the risk of collision. According to Rule 5, radar also must be used for lookout. If radar settings are wrong, it means that radar was not used properly, therefore requirements of COLREG violated again. Rule 7. Risk of collision. Every vessel shall use all available means appropriate to the prevailing circumstances and conditions to determine if risk of collision exists. Proper use shall be made of radar equipment. Assumptions shall not be made on the basis of scanty information, especially scanty radar information. Risk of collision shall be deemed to exist if the compass bearing of an approaching vessel does not appreciably change. Rule 7 is about radar information presentation and interpretation. Wrong display mode, wrong vector mode selection, wrong trails mode selection could be easily considered by court of law as violation of COLREG Rule 7 requirements. If ships maintain proper lookout and use radar properly, about 80% of collisions at sea never happened. So, let's see how to adjust radar correctly and get its 100% of capabilities. To understand how different radar settings are working, important to understand overall principles of marine radar. Radar transmits radio wave pulse. Then it changes to receive mode and listen for echo reflected from target. Then radar antenna turns for few degrees and radio wave pulse send in new direction. After that radar listens for reflected echo. While antenna rotates on 360 degrees, process of sending radio wave pulse and listening for echo repeated continuously. In real life everything happening much faster. Radar sending pulses about 2,000 times per second. Length of one pulse is about 8 million parts of second. Antenna makes 360 degrees turn in about 2 seconds. Radio wave pulse and echo signal traveling at speed of light. Because human eyes cannot see such a fast movements and changes, picture on radar screen looks stable and smooth. So, now you know that radar has two main parts, radio frequency transmitter and radio receiver. Let's check settings of radio receiver. We start with most important setting, gain. What is radio receiver gain? In simple terms, radio receiver gain very similar to brightness setting of TV or computer monitor. If brightness setting is too low, picture barely visible on screen. If setting too high, picture so bright that many details are missing. Same story with radio receiver gain. If it too low, many weak echo signals are not displayed on screen. If gain is too high, weak echo signals obscured by strong noise. Conclusion: gain setting belongs to radar receiver. It should be adjusted in such a way that weak echo signals become visible, but noise, or clutter, is not obscuring these weak signals. Next setting is C clutter. When clutter C is off, receiver gain remaining same during all time when radar listening. When clutter C applied, at the beginning of listening period, receiver gain is at minimum. Then it start increase slowly, up to its normal level. Normally echoes reflected from C waves returning first, because these waves are closest to ship. At that moment, receiver gain is low, therefore C waves echoes are not amplified by receiver and not shown on radar screen. Radar picture on short distance becomes clearer. However, if clutter C setting is too high, together with echoes from C waves, small targets become invisible as well. Here C clutter setting is very high. No C clutter shown on radar screen. Target echo signal suppressed as well and not visible. Remember, purpose of C clutter is not to make radar screen completely clear, but to remove most of clutter, but in same time small targets remain visible. Here C clutter setting very low. Due to very strong clutter, targets are not visible at the center of screen. Here setting of C clutter is correct. You see some clutter and small targets. Rain clutter. Radio waves reflecting from falling rain, snow and low clouds. These reflections create noise on radar screen. We call this noise rain clutter. On radar screen ship's echo signal become easily obscured by rain clutter. Rain clutter setting allows to reduce effect of rain on target visibility on radar screen. Rain clutter is a setting of radar's receiver. Like C clutter, rain clutter changes receiver's gain over time of listening period. In the beginning of listening period gain remain at normal level for some time, then slowly reduced till end of listening period. Echo signal from target amplified for some time. At the end of listening period echo signal from rain not amplified. On radar screen rain clutter reduced and target echo become visible on screen. However, need to remember that, when rain clutter applied, only front of target echo signal displayed on screen. The only transmitter settings available for radar operator is scale and pulse length. Transmission power remains same all the time. Pulse length. Length of pulse dictates discoverability of targets on different distances. Short pulse for short distance, medium pulse for medium distance and long for long distance. If long pulse used, echo signal from target nearby will return before radar change to listening mode. It means targets very close to ship become invisible. Same story with short pulses and targets on long distances. Listening mode will be finished before echo signal reach receiver. And again, target become invisible. Radar scale. Smaller scale, better radar performance. With smaller scale, smaller pulse length will be automatically selected by radar. Shorter pulse length provides better small target discoverability and better radar picture resolution. Select appropriate to navigation area and traffic density scale. Smaller scale better for small targets and buoys detection. Bigger scale good for making landfall or very early big target detection. Adjust gain. Then adjust sea clutter. Do not make screen perfectly clean. Some sea clutter must be visible, otherwise nearby small targets become invisible. Like pirate's boat approaching from quarter. Do not apply rain clutter if there is no rain or snow. Rain clutter makes weak echo signals from small targets and buoys almost invisible for operator. Main problem for radar operator is small targets. Only one way to solve this problem is to practice different settings in good visibility. You will see, at what gain setting small fishing boat will disappear from radar screen. Do same with sea clutter and rain clutter. This way you will find practical limits for settings. And remember, for many reasons, setting limits are not remaining same over the time. Check settings upper and lower. Select appropriate to navigation area and traffic density scale a limit every time when it's safe to do so. Speed input. What speed input to select? Before we decide, let's see how closest point of approach, CPE, and time of closest point of approach, TCPE, calculated. As you see, on-ship speed is not used to calculate CPA and TCPA. Conclusion: for CPA and TCPA calculations, it does not matter if speed log or GPS input selected. On-ship speed input used only to calculate true speed and course of target. One of the most important tools is relative motion. Unfortunately, it is underestimated and poorly understood by many officers. How relative motion looks like? You in the center of universe and everything moving around you. You literally pivot point of universe. This not a joke. This is exactly what you see from navigation bridge of ship in the ocean. In the absence of any landmarks, you have no sense of own movement. For you everything moving around you, other ships, all floating objects and celestial objects. So, relative motion on radar screen precisely matching your visuals, you in the center, and everything moving around you. If something approaching on ship on constant bearing, it means that this thing will collide with your ship. Even if it is ship moving in the more or less same direction in true motion. Based on my 33 years of successful sea career, I would strongly recommend to set radar to relative motion mode and set relative trails. Relative trails allow to locate dangerous target instantly. One glance on radar screen enough to see if any trail is pointing in the center of the screen. Relative trail pointing to the center of screen means that this target approaching your ship at constant bearing, so risk of collision exists. One more example of proper use of relative trails. 8 targets are visible on radar screen. Without acquiring any target, operator instantly see that only 2 out of 8 targets are dangerous at this moment of time. If any target will start maneuvering, In about 1 minute her trail will change direction automatically and it became evident, if it dangerous or not. This is fail-proof lookout technique for dangerous targets, in full compliance with COLREG Rule 7. In this example true trails are used properly. Own ship sailing in TSS, having big anchorage area on her port side. Officer on watch must look for ship leaving anchorage. If relative trail is used, every target will have trail and radar screen will be cluttered. If true trails selected, then only moving targets will have trail. Only moving targets should be acquired by ARPA. Remember, this bad practice to acquire every target on radar screen and monitor CPA and TCPA of every target. Depends on ARPA model, operator able to simultaneously monitor CPA of 6 to 8 targets only. In this example 10 targets on screen. CPA of 2 targets are not monitored. On top of that it is night, and you cannot see navigation light of moving ship, having deck lights of anchored vessels on background. This violation of COLREG Rule 5, lookout. Also, it is illusion, that radar operator able to remember CPA of each target and frequently check changes. Such a lookout technique is not considered proper lookout in the court of law. Congratulations! You watched this video till the end. Now you know how to set up radar properly and able to use radar according to requirements of COLREG. Good luck and safe seas.